So yesterday in class we learned how to multiply using the box method and the FOIL. But today we're going to multiply special cases. Okay, so we're still multiplying polynomials, but we're going to be multiplying some special ones. And this is our first one. It's called a perfect square trinomial. Okay, and this is a polynomial that fits the form a squared plus 2ab plus b squared. And I know that sounds kind of weird, doesn't have much of a definition there, but we're going to, example 1, we're going to look at this, and I'm going to show you how this is the same as that. Okay, so I'm going to use the box method, but first we have to remember that what does, whenever I have a plus b, whenever something's being squared, it means that times itself, right? And since all of this is in parentheses, what this means is I really am saying a plus b times a plus b. So since I'm multiplying both of those together, it's just like every other problem that we've been doing. But let's go ahead and get it done with the box. Okay. So with my box, I'm going to say this is a and this is b. They're both positive, and I just have to multiply them together. I get a squared, and then a times positive b, well that's ab, and b times a, well that's another ab, and b times b, well that gives me b squared. So if I write this out, and the reason I wrote it out this way is because this way you can easily see that your answer comes out a squared, and these two, when you use the box, should always be like terms, so we should be able to add them together. 1ab plus 1ab is 2ab, and of course the last one, there's nothing like, so it just comes along for the right. So you can see that this right here is a perfect square trinomial. Okay? And perfect square trinomials are the only ones when you see a problem that's written like this, with it being squared, it will always be a perfect square trinomial. Okay, so but always be very, very careful. Don't just distribute the two, because that's not what we're doing here. We have addition going on. We were distributing exponents when we were multiplying, and that's okay. But here we have addition going on, so we have to separate them into two separate terms. Okay, two separate binomials. Excuse me. So example number 2, we have x plus 5 squared, and again, this is going to be a perfect square trinomial. So I'm going to rewrite it the way it should be written, which is x plus 5 times x plus 5. And again, I'm going to use my box. And this is going to be x, and this is going to be positive 5. So if I multiply them out, I get x squared. X times 5 is 5x. 5 times x is 5x, and 5 times 5 is 25. So again, these are all positives, and I can write my answer just by bringing them out kind of sideways. If I look at them sideways, I can see there's my first term. These two should be combined to give me my middle term, which is 10x, and then my last term, which is 25. So there's my answer there, x squared plus 10x plus 25. And again, these, whenever you see them, this is always a perfect square trinomial. If you see it, there's actually a faster way to do these, but let's just focus on doing them with the box, or you could use FOIL as well. Okay, this is perfect square trinomials. We also have to learn multiplying the difference of squares. Okay, so the difference of squares is a polynomial that fits the form a squared minus b squared. Okay, so if you notice on the last one, what I gave you was the trinomial, which is usually your answer, but the difference of squares always ends up being just two terms. Okay, it ends up being another binomial. So it's kind of weird, because what we're going to do is we're going to multiply two binomials together, and our answer is going to be a different binomial. But we follow it and do it the same exact way that we've been doing all the other problems. So this one, if you notice, I'm multiplying a plus b times a minus b. And the difference of squares will always fit that form. You'll always have the first two terms in each binomial will always be the same, and the second two terms will always be the same, except that one will be positive and one will be negative. Okay? And that's kind of true of what we have here in example 4. So both of these problems that we're going to do are going to be the difference of squares. But you notice that the first two terms are both x, and the last two terms are both 3. It's just that one's positive 3 and one's negative 3. So, going back to example number 3, I'm going to use my box. And I have a and a negative b up here. And I'm going to multiply it. A times a, well, I get a squared. A times b, well, I get ab. And again, that's a positive. Negative b times a, well, that's negative ab. And negative b times positive b gives me negative b squared. So, if I write my answer out, I get a squared, and when I add these two together, which is going to be the case of every difference of squares, my middle term, since this is positive AB and this is negative AB, they cancel each other out. So really what I do get is I get 0 AB. But whenever you get 0 as a coefficient, we don't usually write that term. Okay? And of course my last one is b squared. So the way I'd write my final answer would be a squared minus b squared. And you can see that it fits the form of the difference of squares. Okay? Let's try it now with actual numbers. So, same exact process. Use my box. This is going to be x, and this is going to be negative 3. X times x gives me x squared. This is going to be positive 3x. This is going to be negative 3x. And again, you can see these cancel each other out. But here I get negative times positive, and I get a negative 9. Excuse me, write my answers out, and I get x squared. These cancel each other out. I'm left with x squared minus 9. Okay, so again, whenever you see the difference of squares, it will always, your answer will always be just 2 terms, as opposed to the 3, which we're used to getting with every other type of these multiplications that we've been doing with binomials. And again, it'll always fit the form of the first term, and the last term will be exactly the same, except you'll have one that's positive and one that's negative. So a plus b, a minus b. X plus 3, x minus 3. Okay? Again, remember these terms that I've been using, perfect square trinomial, difference of squares. They're going to come back to haunt us, and I'm going to expect you to know how to use them when we're talking in class. Okay? Don't forget the question. If you must have a question for class tomorrow. Thanks.